It's our hope. Thank you for starting the recording. It's our hope that the conversation that emerges from these events can inspire some of the future research efforts in this area and to introduce new and interesting ideas to all of our attendees from academia and the industry. We're very lucky to have three eminent panelists with us today. Firstly, I'm going to briefly introduce each of them, and then they're going to take over and quickly talk about where they come from and how they fit into the topic. Actually, I've just noticed that there's a mistake on the slide. The heading should be securing IP and supply chain. It actually says securing machines and processes. That's my apologies for that. So firstly, today we have Rachel Zhu, who is the Senior Research and Development Engineer at Johnson & Johnson Neurovascular Division, Coronavirus in Miami, Florida. She received her MS in Mechanical Engineering from NYU and researched at the NYU Composite Materials and Mechanics Laboratory, where she developed her first medical device. Rachel has had 4 years of experience with innovative design, product, and process development under FDA and ISO guidance in the fields of endoscopic and neurovascular devices. She has received 2 patents and filed 15 patents more in the area of aneurysm treatments. Secondly, we have Mario Mercado, who is the founder and CEO of a mixed reality sports technology startup called Bats Toy, which provides a multi-sport smart helmet and interactive gaming platform. Mario completed his undergraduate studies at Syracuse University, obtaining a bachelor's degrees in both media communication and political science, where he was also a varsity member of the wrestling team. Additionally, Mario did his graduate studies here at NYU and Columbia University, respectively, with a focus on sports management. While at NYU, Mario was the leader of an engineering team that won first place in the university's inaugural entrepreneurial engineering technology competition. Finally, we have Satish, Satish Bukkapatnam, sorry Satish, who serves as a Rockwell International Professor with the WM Michael Barnes 64 Industrial and Systems Engineering Department at Texas A&M University, and the Director of Texas A&M Engineering Experimentation Station, Institute for Manufacturing Systems. He's a fellow of IISE and SME, has received Oklahoma State University Regents Distinguished Research and Fulbright Tocqueville Distinguished Chair Awards. He received his PhD and MS degrees in Industrial and Manufacturing Engineering from Penn State. The Society of Manufacturing Engineers, SMEs magazine, listed him among the 20 most influential professors in smart manufacturing in their inaugural class. His research has yielded 115 journal publications and 73 conference proceedings, 1 US patent with 5 pending, and he's received over 7 million in grants and contracts as PI and co-PI with the government and the private sector. I'm very pleased to welcome our panelists. Now I'll request each panelist to take a few minutes to give an overview of their work related to this area of IP and supply chain management in the face of the increasing cybersecurity risks. I'd also like to tell the attendees that at any time they can ask questions using the Zoom's Q&A utility. And we'll start, we can take some of those questions as we go, especially as we open the panel for the broader discussion, which will happen in a few more minutes. So Rachel, why don't you get us started?
Okay, sounds good. Thank you, Hammond. Let me share my screen. Can everyone see my screen?
Yes, we can see that, Rachel.
Okay, perfect. Well, good morning, good afternoon, and good evening, everyone. My name is Rachel Xu, and I'm a senior R&D engineer working at Johnson & Johnson. It's an honor for me to be here today. And then the topic that I'm presenting is securing intellectual property through innovation. First, a little bit about me. When I was a graduate school student at NYU, I was fortunate to be a research assistant for Professor Nikhil Gupta at NYU Composite Material and Mechanics Laboratory. My project was to help develop an endoscopic device to restrain the torque and the motion of the endoscope without the need of being held by a physician or technician. It was from that experience that I learned about medical device design, utilizing patents for unmet user need, iterating design with physician and 3D printing. All of these experiences were important for me to become an R&D engineer, and then it also helped me to land on my first job. Another project that I worked on is an early feasibility evaluation on a lightweight radiation shield that utilizes composite material. that experience also aided me for my second job at Johnson & Johnson. So my first job out of graduate school was working in the beautiful city of Clearwater as a product development engineer in an endoscopic company called Endotherapeutic. I was a project lead for an endoscopic injection needle device that essentially inject ink to mark the examination tissue and inject saline to raise the abnormal tissue to aid for endoscopic tissue resection. I also worked on the endoscopic retrieval net device that retrieve foreign body, excised tissue, such as polyp. So this device that you see on the right-hand side is around a 2-meter device and essentially composed of 3 parts. First, on the distal end, there is a snare loop and then also a mesh. There's a snare loop and then a mesh on the distal end. And then in the body of the device, there is a long sheath with a wire within the sheath. And on the proximal end, there is a wire that's being connected to the handle. So when the physician is ready to actuate the device, essentially what the physician will do is actuate on this handle to translate the wire along the length of the device and then retract the stainless steel wire into the sheath in order to create a pouch in order to capture the foreign body. So looking at all of these 3 devices over here, at a glimpse, it might look like all of these devices are the same. But if you look around the snare loop of all of these 3 devices, you can see the small differences between all of these 3 devices. So the first device is one of the first retrieval net product that's on the market. So for this product, its patent claims state that the net mesh needs to be securely attached to the snare loop of the device. So when the physician is ready to retract the device, it essentially retract the snare loop and the mesh together in order to create a pouch. This device in the middle is the second product after this product has already been launched. In order to work around this secure attachment patent, what this company did was they would thread this snare loop around this mesh in order to create attachment without the claim securely attached to the mesh. But what this company did different is that there is a little thread over here. So this thread is essentially loop around the mesh and then being attached to the long wire that's also connected to the handle end. So when the physician is ready to actuate the handle, it will essentially grab the wire and then the thread and then the snare loop and then the mesh together in order to create a pouch. So their patent claim is that the net is attached to the movable member of the system, which is a wire along the entire length of the device. And this is our product. So looking at this net mesh, it almost looks like these 2 parts are identical. So this device also works around the first competitor's patent by having the loop threaded around the mesh. But what's different about this device is that instead of having this mesh securely attached to a movable member, what happened is this thread is being attached to a hypotube that's floating around the movable member of the device. And then what you see here is a crimp feature that crimps the snare loop onto the wire. So during retracting of the device, this crimp feature, it can push on this hypotube and then bring the entire system back into the sheath. So what this thread does is that it will capture the mesh with it as the device is being retracted into the plastic sheath in order to create a pouch. And the second patent claim that we have is that you can see there is a zigzag feature on the snare loop. So during the recapturing of the device, What this zigzag do is that it will capture the mesh and then catch the mesh with the snare wire as the wire and then the mesh is being dragged into the sheaths. So our patent is that the net is attached to a member that is independently floating from a movable member. So as you can see that all of these ideas are essentially similar looking product, but what's different is that there's some unique feature. So understanding the competitor's product and then also the competitor's patent claims allow us to pinpoint the area that we need to tackle and then secure our own patent. And through the development of process, all ideas need to be protected, even the ones that's not being used. So this zigzag design, we did not end up using it for our device, but we still filed the claim because it can potentially be used for a future product or prevent the competitor from using it for their future product. So after working at Endotherapeutic for a few years, I moved to the beautiful sunny Florida, Miami in Florida, and started working for Cerenovus, which is a Johnson & Johnson company. And then the device that I'm working on is aimed to treat aneurysm. So an aneurysm is a bulging in the blood vessel caused by weakening in the blood vessel wall. So our focus is the cerebral aneurysm. So here, the picture in the middle, this is a healthy vessel in the brain. And the one on the right is the vessel with an aneurysm. So an aneurysm is essentially like a berry-shaped type of weakening of the blood vessel wall that's hanging around a healthy blood vessel. 1 in 50 people in the US have an aneurysm, and each year, 30,000 people in the US suffer from a ruptured aneurysm, and half of these cases resulted in death. So the best mitigation of treatment is to prevent the aneurysm from rupturing and promote healing over time. Traditionally, aneurysms were being treated with a surgical procedure by putting an aneurysm clip around the aneurysm. So the clipping is invasive because it is a surgical procedure, and it can take the patient a long time to recover from the procedure. Since the 1990s, new endovascular technology has been developed to treat the aneurysm neurovascularly. What it means is that the device will essentially go through the femoral artery into the aortic arch, and then go through the surgical artery, and then eventually get onto the brain artery where the aneurysm site is. And then the embolic coil is essentially a type of platinum implant that aims to fill the entire aneurysm to prevent the blood from flowing into the aneurysm and promote healing over time. Johnson & Johnson developed the first hydraulic embolic coil in 2002, so a few years after the first invention of this technology. And in 2015, we invented the enterprise stent, which is being used to facilitate coil. So this stent that you see over here is essentially a self-expanding stent, and it can be positioned around the aneurysm. So this stent will be placed around the aneurysm first, and then the physician will then insert the microcatheter into the aneurysm, and then to pack this aneurysm with embolic coil. So what this stent does is that it will prevent the coil from falling into the parent artery, which will help to treat some aneurysm in difficult anatomy. This aneurysm, this device on the right-hand side is one of the latest product that being launched in Johnson & Johnson. So this product is being launched in 2019, and then it's called Pulse Rider. So essentially, this is an implant device that can be used to treat bifurcation aneurysm. And bifurcation aneurysm is traditionally difficult to treat, and then it also counts as 60% of all aneurysm. So what this product does is that it sits at the parent artery wall, and then it has these two features that's able to support the bifurcation aneurysm to prevent the embolic coil from falling into the parent artery. So all of these, so new patents are being filed every year as a new concept, and some concept can be developed as new technology. So innovation also happen by improving on the existing technology by creating new patents. So this is the embolic coil iteration that Johnson & Johnson produced from 2002 to current. So as you can see that this is the initial coil, and then this is just a simple platinum implant that has multiple loops. So new technology has been developed based on this existing platform to improve the device performance and the functionality. So this device over here, this first loop is called tight distal loop. It's essentially 1/3 of the diameter of the rest of the coil. And then what it does is that when this device is first deployed to the aneurysm, this tight distal loop, it will tend to conform to the aneurysm wall, which prevents this coil from falling into the parent artery. And this is another device that Johnson & Johnson has developed. So this embolic
Hi,
coil.
Rachel.
Yes.
Hi, Rachel. Sorry to interrupt you. Could you finish this in the next sort of 30 seconds so we have time for the other presenters as well?
Yes, this is the last slide that I have. Yeah, thank you. So this last coil is made of a triangular shape. It has improved stability, and then it's able to fill the aneurysm with a high packing density. With this coil over here, it has a suture member, and then it's wrapped around within the embolic coil to prevent the stretching of the coil while maintaining the same shape and then flexibility of this product with the previous product. And then the latest technology that we have is this coil with a random loop design, and then it's able to seek and fill the open space to increase the packing density to treat the aneurysm with the detachment time being only 0.3 second detachment time. So securing IP, it can happen through understanding the competitor's product, and then it also happens when a company keep developing on new technology and then also improving upon the existing technology. And now all of these innovations essentially happen to make a product more competitive, and then also at the same time to benefit patient as well. Thank you.
Thanks so much, Rachel. Okay, Mario, would you be able to introduce yourself quickly? You're still muted, Mario.
Okay, I'm just going to share my screen.
Cool.
Okay. So good afternoon, everyone, wherever you are around the world. My name is Mario Mercado, founder and CEO of Batois. We are a mixed reality sports technology company. We actually started Batois at NYU, as mentioned by Hammond, by participating in the engineering competition that was held at the university, of which we won for our multi-sport helmet. Initially, the use case was for wrestling. And let's see. So basically, we developed a product, a wrestling headgear using traditional injection tooling methods to make our helmet. And we realized that because of the current supply chain issues that were happening during COVID, that we wanted to transition to additive manufacturing in order to achieve some of the goals that we wanted to reduce cost and also meet the requirements from our stakeholders, our investors, our customers, operations, and suppliers. And we felt that additive manufacturing would be the way to go. And as a result of that, we're looking at how that's going to optimize our supply chain, as well as potentially even securing additional IP as we continue to manufacture our helmet with this new and exciting process. So as you can see, our solution was creating a really cool helmet initially for wrestling that's now for multi-sport. And this is what it looks like. Currently, we are in market. We have many different SKUs, and we believe that the additive manufacturing will allow us to add to this. But as a result, with the name of this series, Cybersecurity, we do understand that there are technical challenges that need to be met in order to secure your IP and your supply chain through cybersecurity technology, whether it's watermarking technology or other different types of technology to secure one's IP. And as many of you have seen in the news, particularly here in the United States, where cybersecurity theft is really a major issue, having cybersecurity for startup companies such as ours or even larger companies is a major consideration. So I'm looking forward to answering any of your questions and also discussing other issues with the rest of the panelists as we continue along the series. Thank you.
Great. Thanks so much, Mario. And finally, Satish, could you give us a brief introduction?
Yeah, sure. Let me share my screen. All right. Are you able to see the screen now?
Yes.
Excellent. All right. Just begin with a quick introduction. Good morning, good afternoon, everyone. I would like to talk about kind of an academic side of cybersecurity in smart manufacturing systems. And let me kind of bring everyone up to speed on how I think about smart manufacturing, because it can probably mean different things to different groups. At the outset, with the advances in artificial intelligence, AI, data science, advances in sensor technologies, communications, 5G and beyond, there is a fantastic opportunity to transform manufacturing systems, the way we make things, to make them significantly more efficient and performing much better than what we are able to see in the industry today. And the way we kind of put these technologies together is what we see as smart manufacturing. And what I will try to kind of touch upon in the next few minutes is provide an introduction to where we are from, what is Texas A&M doing in manufacturing area, and then talk a little bit about the context of the cybersecurity issues that emerge in this smart manufacturing environments. I'm part of the Texas A&M manufacturing group, and we are one of the largest manufacturing groups in the nation. We have about 40 colleagues. However, our focus are confined to the following 4 areas. We look at additive hybrid technologies and processes, and smart manufacturing, precision manufacturing, and also nanobio focused composite manufacturing. Most of my research focuses on smart manufacturing here. And we have some outstanding built-in facilities. We have several additive manufacturing equipment. As we speak about, there are 7 or 8 metal additive manufacturing, several for composite, as well as ceramic material manufacturing, and a few for polymers. And we have multiple built-in labs, both for education as well as research focused in manufacturing. And more interestingly, we have initiatives where we are engaged with 6 manufacturing USA institutes, and we have a growing portfolio of international partnership, especially with France and India. And we are gaining significant body of expertise through people and their work in the areas of thermomechanical processing and smart manufacturing. And we have multiple degree programs and certificate programs, especially in the smart manufacturing focused aspects of manufacturing. And I look forward to discussing these with you as this conversation emerges. And let me quickly change the tack a little bit and talk about what is the cybersecurity issue that emerges in the smart manufacturing arena. If you look at the manufacturers across the nation, if not the world, 8 out of 10 are what we call as micro, small, and medium, that is MSM manufacturers or MSM enterprises. And they form the 80% of the industrial supply chains as of today. Right? And if you look at the trends in the industry, most of the conglomerates, as well as the big industry, is increasingly moving towards digitalization and adapting various smart practice. And then, as many of you may have heard about, they are moving towards adapting and embracing this fourth industrial revolution or Industry 4.0. However, if you look at these small, medium, and micro enterprises, they need significant resources, and they want to be part of this. The way they are connecting to this digital thread that's emerging actually is posing significant cybersecurity vulnerabilities. However, there is a fantastic opportunity that is emerging. Actually, that is in fact been accentuated because of the recent pandemic, which is one of transforming this entire manufacturing into a service, or MaaS. So the idea behind this MaaS is to make the parts that are well qualified on demand at the point of need. So to give a contrast here, the way things get made, especially for custom products, high value products, is the customer makes a request, places the order, the part gets made at a remote location, and it gets delivered after certain, maybe weeks, and if you are lucky, and if things are stored in days. But again, somebody must have made the request, and then it must have taken about a few weeks in terms of a turnaround time, however the volume. But now the service-oriented manufacturing architecture enables more democratization, that there will be all these small and medium enterprises who could somehow digitally get the instructions of how to make, and then make these locally, and then deliver it back to the customers. It is evolving to a point, especially with the growth in additive manufacturing, that local kiosk can be you, in the sense that you could actually print it to your own into your own printer, and then fulfill your needs. So this type of democratization is happening, and then it's a trend that many agencies as well as think tanks have strongly noted. And this transformation, as I mentioned, poses significant cybersecurity vulnerability for a simple reason that unlike the big companies, the small companies don't necessarily invest in many of these cybersecurity practices as well as technologies. And when we try to look at it, slice it a little bit more, I will try to be quick, but feel free to ask more questions. If you think about the cybersecurity vulnerabilities, they occur at 3 different levels. And from what I've heard from various colleagues of mine, as well as people from the industry, the 7 out of 8 folks say that their number 1 concern is basically the theft of IP or compromise of IP. And that actually corresponds to things that happen at the design phase. How we create the product, similar to what Rachel mentioned, right? How do you protect this? And how do you make sure not just the design, but it's the recipe for making it is also well protected? That remains the number 1 concern. Second thing is the issues that relate to tampering with the process as it's being made, or tampering with the products as they're being shipped. these are all points of cybersecurity vulnerabilities that one needs to be aware of. So the entire manufacturing supply chain or the process chain opens itself to cyber vulnerabilities, especially when we open the entire manufacturing into a service-oriented architecture. At Texas A&M, collaborating with NYU, we have been looking at various ideas where we can instill cybersecurity by design. And also we are looking at a almost like a Netflix-based models, basically using streaming idea to be able to secure the instructions or the designs that actually move through the digital thread from the manufacturer to the designer and so on. And also we've been working with the controller, essentially trying to look at ways in which we understand the various vulnerabilities and then trying to secure the controller through some ideas such as dynamic watermarking as well as forensics and so on. So this is in just what we are actually trying to do. And there is a lot more that needs to happen when we look at cybersecurity vulnerabilities in smart manufacturing. So with this brief introduction, I wish to turn it over to Hammond.
Thanks so much, Satish. So thank you everyone for your introductions and helping to set the scene for the attendees. So what we're going to be doing now is opening the floor essentially for questions. So attendees, we'd really appreciate it if you put all of your questions into the Zoom Q&A system. We've got a few questions of our own that we'll get started with. But remember, yeah, you can add any questions at any time, and I can see some people already starting to load some in. So the first question I want to open to everyone is, pretty topical at the moment, is a number of recent hacks have happened through and into industries through technologies which allow for remote work. So for instance, teleconference software or Zoom software like we're using right now, remote desktops and things like that. So what are your thoughts on how businesses can prepare for this, especially as people in the field are pushing for more remote work? A lot of tech folks, especially in my background area and, in the tech fields, are saying, we've just worked from home for the last year and a half. We want to keep working from home. We quite like working from home. So do you think that this is going to introduce more risks for protecting your IP and that sort of thing moving forwards?
I'll take this question first. So I think, yes, we're actually going through a similar exercise now. We've added additional people to our team. And as such, we've had to make sure that everyone is using the same web service, email service, and making sure that that it's actually robust. So we're using Microsoft 360. And then also we had to purchase recently a dedicated server just for our needs, so that we can actually control the files even more. And just educate our staff and members of our team on not opening up emails that may seem fishy, and just being just more judicious and having better diligence of making sure that the emails that they do open are from the team. But also we've actually used even Slack. So we're using more channels of communication that are directly for the teams, to where we're not having one area of communication just funneled. So instead of just focusing on emails, we're using other channels such as Slack, such as Notion or Asana, that are specific to team members' work, in order for us to sort of spread the risk of hacking.
Okay, thank you. Rachel or Satish, did you want to add anything to that?
Yeah, I think Mario kind of mentioned it very nicely. In fact, securing your office processes is no different from securing a manufacturing supply chain from an IT side. So again, the vulnerabilities are very similar, and then there is always a concern on ensuring the IP is well protected. And also in many cases, especially for the digital thread that actually is getting more voluminous as we speak. Protecting it actually becomes a major challenge. And another point that I would like to mention here is the issue of phishing, and as well as other types of kind of external stimuli that actually enhance the vulnerability. And there has to be a strong quarantining practice that one needs to enforce, not just in office environment, even in the industrial environments. That can be very helpful.
That's really well said for Satish and Mario. And I just wanted to add that for me, from a user perspective, I work for a corporation. So when I'm in the office environment, I do have secure network and secure internet. But I've been working from home for the past year. And then what happened when I'm working from home is that they will provide us with the PIN ID. So in order for me to get onto like the patent application website where I can file the patent, I will need to get through certain internal company network and then to put in my credentials. I think these practices, it helps to secure the patent and then also secure the information within a corporation.
Oh, thank you. So sort of building on that, recently we've heard of a number of other software, so specifically software supply chain attacks. So the most famous of that will be the SolarWinds attack that happened recently, which managed to infect a number of US government agencies and also corporations. So sort of related to that idea, what other or what kinds of supply chain attacks do you think are possible in your own spaces? Which do you think are more or less likely, and what should you as employees and as organizations be looking out for to even tell if you have been a victim?
Well, as we're looking to have additive manufacturing as part of our supply chain, it's really looking to protect that IP and looking at cybersecurity software where the CAD files can be watermarked, but then also seeing how blockchain can potentially have any impact or utility in what we're doing. We see that blockchain has been associated, specifically with cryptocurrencies and now NFTs, non-fungible tokens. But there seems to be a greater utility potential of blockchain as it relates to supply chain manufacturing. And I think that more investigation could be used in this use case, which could provide a lower cost way of authentication of cybersecurity of a company's files. And we're actively looking into this now as we go into additive manufacturing. But the other answer to your question of how do you find, it's really difficult because some of these emails now are very sophisticated and where it looks exactly like it's coming from a supplier or an internal collaborator. And one really just has to be just diligent, but unfortunately you have human error. And I think this is where blockchain could potentially be good, where it reduces the human error. And then also potentially even looking at user authentication, as Rachel had mentioned, of what she uses at Johnson & Johnson.
Great point, Maria. I think the issue of looking at vulnerabilities in a supply chain, I think needs to be a more holistic. But at the outset, the vast majority of the vulnerabilities in supply chain are no different from the vulnerabilities in any IT system. However, there are a few additional details to kind of that might be slightly different that I will touch upon. Again, this is coming from an academic world that I live in, as opposed to I would say the real world that Mario and Rachel live in, I guess. If you look at in a supply chain scenario here, the nice thing is the product that has been made is not getting transformed, but the various entities in the supply chain can actually suffer from maybe one of the following 6 or 7 types of attacks. You can still steal the IP, basically take the product and then reverse engineer. And the worst thing is tamper with the data, because most of these supply chains are nowadays connected through a digital thread, almost invariably. Tampering with the data where you're trying to give wrong information about the amount of number of items stored in your inventory, or the amount of content being shipped, and all that can create some serious disruptions to the entire supply chain. People talk on bullwhip effect and so on. These things can origin by simply tampering with the data. Of course, denial of service, side channel attacks, these are all possible, but the data tamper can have much more serious ramification in a supply chain scenario compared to many other types of attacks. And in terms of countermeasures, of course, no countermeasure is going to be completely foolproof, in the sense that it can never eliminate all forms of these, but they can create serious hurdles for any vulnerability from being realized. We can actually watermark things, do nice kinds of obfuscation. And as Mario mentioned, we can actually use blockchains effectively and so on. So protecting the supply chain is an important concern because it will not only affect that particular point, but it can affect the entire enterprise. So yeah, thinking about that, I think will be an interesting endeavor for both the academic world as well as the industry.
Yeah, I actually want to build on that. There's been about 5 people from the audience that have asked similar questions around watermarking. So both of you sort of mentioned watermarking as a kind of defense to this. So I'm just going to try and bundle all of these questions together into one question. So just give me a moment to phrase that. But essentially, what are the sorts of methods of watermarking that you would be using? You know, are they static? Are they dynamic? Is there anything that can be done with like streaming, like you know, DRM for digital media? And also, how are people, you know, say I'm the end user, I buy a product, it's got a watermark on it. How do I verify that that's the real watermark and not just a counterfeit watermark? Maybe Rachel can lead us with that. Are the Johnson & Johnson products that you work with, do they have watermarks on them? And how might someone verify that they are the real watermark versus a counterfeit product with a counterfeit watermark?
So I personally don't have any experience with watermarking, but what I have experience with is I have been to a convention show and then I have seen product that looks identical with our product. Because what happened in the US is that when you file the patent is protected. And then other competitor company, they can take your idea and then they can reverse engineering and then they can work around it, but they will have to stay within the legal system and then come out with their own idea in order to produce the product. And then what happened was some foreign company is that essentially the moment a product is launched to the market, that product is vulnerable and exposed. Like anyone can buy a product and take it back to their lab and then dissect it to understand all the numbers. So I think sometimes what happened with some foreign companies is that they will do exactly, you know, what I just described, and then to produce a counterfeit product and then just sell in their own country, which can be problematic when this original company is trying to sell their own product to that country. But I think with the legal protection system that we have right now, not just in the US, but also trying to be pushed around the world. And then I think that does have an effect for foreign companies to understand that intellectual property is valuable and there is consequences for counterfeit and reverse engineering.
Great, thanks, Rachel. Mario, Satish, do you have any thoughts on watermarking as well?
Well, Hammond, I think what you described is a game of cat and mouse. because as you mentioned, what happens how does the end customer know that the watermarked product is not really, in fact, the true product or not? So it's essentially cat and mouse. And I think that you just have to be one step ahead of the curve. For us, we are just beginning to investigate these types of watermarking cybersecurity technologies. So I could not give you or the audience a specific answer as to which type of technology of watermarking technology that we're using, because we're just looking into that now as we develop a comprehensive ecosystem around our additive manufacturing strategy.
Great, thank you.
Let me add to a couple of points that Rachel and Maria have nicely laid out. From a watermarking standpoint, you can watermark the product and you can watermark the process, essentially the controller too. In fact, if you look at the work that's been happening, there have been a lot of academic advances and also some patents that have come out on watermarking both product as well as processes. As we speak, Rockwell and Siemens are actively pursuing research in creating watermarks around their controllers. And in terms of watermarking, you can actually think about both visual as well as embedded watermarks, right? Even the visual watermarks, basically the signatures that we put, they themselves are considered to be a good hurdle that prevents, or basically that needs to be overcome before someone can just go about directly copying your IP. So that is found to be a good deterrent, given the legal regime as well as the rule of law that prevails in most parts of the world that we live in. There is also a lot of work related to embedded watermarks. And these things are becoming more and more in demand. The embedded watermarks have been studied in the pharmaceutical industry for some time now. Some of the practices on standardized identification of components and then kind of creating provenance through these embedded watermarks have been pursued on case-by-case basis. Having said that, the point that someone has raised about how do you verify these embedded watermarks, that remains a bottleneck. And those of us who are interested in this area, I think that's a fertile area to look at, because coming up with an efficient and effective way of detecting these watermarks and coding these watermarks, I think it would be a fascinating area to work in and then make a major impact.
Great, thanks, Satish. So there's actually been a very interesting question that's come in that's talked about essentially, for some reason it vanished. I think that maybe they deleted it after they posted it, but I liked it, so I'm going to recite it from memory. But they said something along the lines of what's the approach that organizations should be taking sort of to verify that they aren't getting attacked in the same way that another organization was attacked. So around sort of the sharing of ideas. So for instance, I mentioned right at the start that a number of organizations have been attacked the same way with regards to remote desktop software, right? We've seen a couple of TeamViewer things, and that people come in and they ransomware the data. So it seems to be that that the attackers are almost following a script, right? They've attacked one company, they've worked out a way of doing it, and now they're trying it out with other organizations and companies as well. So should companies be more forthright with what they share with arounds to their cybersecurity? And this happened to us, this is what went wrong. Maybe everyone should avoid doing the mistakes that we made. Yeah, I guess just kind of your thoughts on how you might avoid copycat attacks.
I agree with that. I think, for example, we are currently investigating an NFT platform, a blockchain platform, and we use Discord. And we found that on Discord, there are many different channels that provide from developers from all over the world that really want to share information. And even hackers share information because that's the way that they improve their hacking, and they want to get their kudos, and it's somewhat like a hackathon for them. So I think by developers sharing the problems that they have within the community on these channels such as Discord, and to exchange ideas of what problems they're having, because your stakeholders are not just your investors and not just your customers, but I think it's also the intellectual stakeholders within the development community at large, because they too want to understand what's going on, what new algorithms or what new software is being used. And I think that companies, and we do that, we encourage our development community. There's actually a book, I'll show you now. It's called, Ask Your Developer, actually. It's a fantastic book by Jeff Lawson of Twilio. And in the book, they encourage your developers to be part of the solution, and as a business person, not tell the developer what the solution needs to be, but tell them what is the problem. Because the developer wants to figure out the solution. They don't want to be told what the solution is, because it takes all the creativity out of doing it and the sharing of ideas. So I think as an organization, whether it's in academia or in professional, if you encourage your developers to speak about these problems and come up with solutions, it democratizes themselves and empowers themselves to find the solutions to these problems.
All right, thank you.
Yeah, great point. Great point, Mario. Actually, it would be almost imperative for the industry and academia to come together and create a catalog of the various different attacks that are being faced by the industry and various different organizations. But the issue is, I don't think so any organization worth its salt would like to openly display their dirty laundry, right? So that's what it is. Pardon my colloquialism here. So there has to be a very systematic and concerted effort whereby we can create a platform that will create the trust within the industry as well as the various different organizations to place their vulnerability listed so that it becomes a little bit more visible, and thereby there is a way in which we could propagate the emerging challenges as well as emerging vulnerabilities so that they could be fixed in a more timely fashion than what could be done otherwise. And I cannot emphasize this enough. And many of us in the academic world have been thinking about creating this community that can, community of these trust holders who can actually be feeling comfortable to participate in such type of a endeavor. I think more needs to happen, in my view.
Great, thanks, Satish. Now we're running close to time, but I have a few quick questions that I'd like to go through. So this one's for you, Rachel. Someone has asked, how do you tell that, since technology is changing so rapidly, in the duration of months or years, how does an organization like Johnson & Johnson determine what is worth patenting versus what is worth simply keeping your production methods a secret and keeping your product a secret?
Thank you for that question, Hammond. So essentially, when it comes to our cooperation, there are two things that we're trying to protect. First is trade secret, which can relate it to a process or a way of making an implant that we don't want to disclose to anybody. And on the other hand, we also have the IPs that we want to openly claim the design and then to protect ourselves from the competitor. And then to echo what Satish was saying just now about the importance of community and then the importance of the cooperation to collab together and then to work together, I think that is very important, because looking at the competitor's product and looking at what is the how they perform and how their functionality, that's actually how it can help a company to identify what is the unmet user need. Because at the end of the day, we like to help physician and then we like to help patient. So essentially, we're trying to aim at the area where the current product is lacking. And then this is where we know this is the focus that we aim. And then here are the patents that we can come up with in order to tackle on this area. And then by all cooperation, essentially doing the same thing, we're essentially improving the industry altogether and then to coming up with innovative solution to solve a problem and help the patient.
Great, thank you. And maybe a quick question for Satish. Since you're working in the academic space, where do you see the future of cybersecurity of digital manufacturing going? You know, what's the next big thing that you think is going to be coming?
I think the products probably will have, product and the processes will have a lot more of these cybersecurity countermeasures built into them. In other words, we need to be thinking cybersecurity more organically. So essentially, right from the upstream stages of design, cybersecurity should be consciously brought in. And it's becoming a little bit more imperative, or at least prominent, because of the trend that we are observing towards increased digitalization as well as smartification of manufacturing. It becomes almost essential.
Great, thanks, Satish. And one last question for Mario. So Mario, you've mentioned blockchain a couple of times this afternoon, and we've had a couple of questions from the audience as well. But essentially, these boil down to, you know, blockchain is a somewhat controversial technology. You know, it's got advocates and it's got people who think it's not so useful. So how do you feel personally about it? And do you think that it has definitely got a place coming into how we might use it for securing logistics or digital product security?
Yeah, well, I think it would be, it would not be a good practice if the assumption were made that something did not work. There can be utility there. So you have to see what works, because if you just blind yourself in saying that, well, it doesn't work just because you think it doesn't work, then you may never know what's possible. And that's what the beauty of cybersecurity. You have to see what is possible in order to allow yourself to find the answer that you need in order to protect your IP.
That's a really good answer. Thanks, Mario. And very lastly, this is just the last question for each of you. For those students or people who are looking to work in this area or take a career in the area that you're in, with regards to the product design and the looking after the IP and the supply chain and things like that, what opportunities are you aware of within your own organizations that might be available for essentially, you know, new researchers or interns or students?
For us, it's all the above. We actually have interns from the computer science program at Columbia, 3D modelers from Pratt University. We're looking for interns and full staff on our back-end development for cybersecurity, as well as a number of different CS roles within our organization.
Thanks, Mario.
Let me quickly mention there are two aspects to it. Those of us who are in the manufacturing area, there is a fantastic opportunity for us to reach out to folks from computer science as well as electrical engineering and so on, so that we can embrace some of the advances that are taking place in the IT world to meld it with our deep knowledge of manufacturing to come up with very innovative solutions for cybersecurity. In other words, computer science alone will not be able to solve the cybersecurity problems in manufacturing. It's us manufacturing folks need to come up with innovative solutions. And again, for those of us who are not manufacturing folks, computer science, electrical engineering, and what have you, there is a fertile area of extreme importance to the nation as well as the world of protecting the IP. And I would like you to think about manufacturing as an area for you to kind of engage your research as well as our other endeavors. So it's a call for movement for both manufacturing as well as non-manufacturing students to engage in cybersecurity challenges in manufacturing.
Great, thank you, Satish. And finally, Rachel.
Yeah, so Johnson & Johnson is one of the world's largest healthcare company. So I think for all the audience over here, if you have a degree, if you're passionate about what you do, there is a position in Johnson & Johnson. I think that would be fitted for your skill set. But for our division, we essentially produce product that treats hemorrhagic stroke and ischemic stroke. So if this is an area that you're passionate with, the areas we always looking for R&D engineer, process engineer, and manufacturing engineer, and then also people that will be working at marketing. So I'll be happy to answer any question or email later if I can help with anything. But I just like to add that when it comes to a student looking for a job, people will always think qualification is so important, your credential is so important, but also at the same time, I think your drive for a position, how much you're passionate about something is equally, if not more important, because this is a value that can indicate that you're a quick learner and you're willing to give it your 120%. And then I think that's what a company is looking for also.
Great, thanks so much, Rachel. So I'll just quickly share my screen again and just say thanks again to all of the panelists that joined us today, Rachel, Mario, and Satish. It's been a really good conversation. And for those that are interested, we have an upcoming what's called the Hack 3D Summer Challenge for NYU's Seesaw this year. And this is a competition that anyone can join, students or professionals. And the top 3 teams will be able to join from this competition into our competition in November. So this is a challenge that really combines your knowledge in, say, additive manufacturing and 3D printing, but also within the security features of computer-aided design. So in the past, we've had things like 3D puzzles and ways of identifying embedded watermarking codes and things like that. So if this area interests you, please take a look at our Hack 3D details. The website link is down the bottom there, and you can have a look at some of our past challenges as well. Thanks again to our attendees, the National Science Foundation for sponsoring us, and the NYU Center for Cybersecurity, and once again to our panelists, Rachel, Satish, and Mario. Thanks, everyone.
Thank you. Thanks, Hammond.
Thank you.